All right, so we're going to continue our conversation about linear inequalities, and what we're going to do today is we're going to shift from graphing linear inequalities to solving linear inequalities. All right, and you can see that that's our next standard here, 14.1. I can solve linear inequalities. Now, there is a relationship between what we were doing and solving, just like we talked about earlier this year when we graphed systems of equations and then we went to solving. All right, so we're going to try to make that and bridge that connection a little bit in this lesson before we get into the mechanics of solving. But before we get to that, we've got an opener. So solving is a very big piece, all right, of what we're going to do today. So I want you to go ahead and do the opener here. I want you to solve this equation. All right, so go through that process, get your answer for x. So pause the video, take a minute or two to solve that opener problem, and then turn it back on, and we'll see how you did. All right, so I've got the answers here. All right, so I'm going to just throw that up right here. All right, so remember that we want to take care of those grouping symbols first, so we have to distribute on the left side. Okay, then we want to combine like terms on the left side. Now, what we want to do, and here's one of our fundamental rules, all right, about solving, is we want to get one side of our equation equal to 0. Once again, it doesn't matter which side, left side, right side. In this case, I went ahead and got the right side equal to 0. So since I had a positive 2x, I subtracted 2x from both sides. Since I had a negative 4, I added 4 to both sides. And that gave me negative 5x plus 15 is equal to 0. And because we know once we get equal to 0, we can use the 0 property of addition to help us. Because what plus 15 is 0? It would be negative 15. So that means negative 5x has to equal to negative 15. And then we get to a multiplication problem here. Negative 5 times what is equal to negative 15? And the answer is x equals 3. All right, so now here's the good news. This exact skill we're going to use again with solving linear inequalities. So the way we solve linear inequalities is no different, all right, compared to how we solve equations. Now, how we finalize our answer, we're going to have an additional step. But the first part of the problem is going to be this skill set, which is why we started this in our opener. Okay, so now, how do we get to inequalities, all right, from equations? So now, let's look at the graphs here. So now let's go back to our system of equations. So what I have done is taken the two lines here, and I've graphed them. And then if I draw a line through where they intersect here. So let me do that real quick so we can see there's a point of intersection right there. I'm going to draw that vertical line right through that point of intersection. And notice they intersect at x equals 3. All right, so remember when we solve an equation, that's what we're looking for. We're looking for that x value where those two equations are equal. All right, so as x equals 3, just like we did above here. So now, here's what an inequality is doing. So it's not looking for where they're equal. It's looking for where one graph is greater than or above the other, or where one graph is less than or below the other. All right, so now let's look at these graphs. So here, I'm going to highlight this in green here, which is this line right here. All right, so that's going to be green right here, and that's going to be green right there. All right, and I'm going to highlight the other equation, all right, 2x minus 4 in yellow here, just to give us a visual for what we are asking. So we can kind of see how that is all going to connect, all right? So notice where they're equal is the point of intersection. That's at x equals 3. But notice, if I just cover up, I'm going to look at the left side here. All right. Okay. Let's see if I can pull this over here and just kind of move it a little bit here so we can still see everything. All right. So I'm going to cover up the right side here and look at just the left side here. Okay. So now when we look at that, notice the green graph is above the yellow graph here. It's greater than the yellow graph. That is what this inequality is asking. Notice it says, where is the green line greater than the yellow line? Where is the green line above the yellow line? So what we can see is it is to the left of that point of intersection. All right, so at x equals 2, x equals 1, x equals 0. Now, how do all of those values compare to x equals 3? All the values to the left are less than. So on that interval, it's going to be x is less than 3. So that's the major difference between an inequality and an equation. With an equation, we're going to get a finite amount of points of intersection. Okay? Well, with an inequality, we're going to have an interval. All right? So for every value to the left of that point of intersection, the green graph is going to be greater all right, than the yellow graph. All right, now look at this one. It says, where is the green graph less than 2x minus 4? So where is the green graph below 2x minus 4? Well, let's look at the other side now. All right, maybe I need to fold my index card in half here so we can see it a little bit better. So now, turn my graph. All right, so now let's look at to the right of that point of intersection here. All right, so now notice on the right side, all right, the yellow graph is now above the green graph, all right, and the green graph is below the yellow graph. So the green graph is below or less than for every value to the right of that point of intersection. Well, notice all the values to the right of 3 are bigger than 3, 4, 5, 6, 7. So that solution now would be x is greater than 3. All right? So the point of intersection, all right, when we solve an equation that tells us where they're equal. And then on one side, one is going to be bigger than the other, and then on the other side, one is going to be smaller than the other. And that's what we're looking for with an inequality. So now, how do we do this without having to graph and do what I just did? Because that would be a long process, right, every time, right? To graph each function, find that point of intersection, highlight, look at that, right? That could be very cumbersome, all right? So what we're going to talk about today is kind of an analytic process to doing that. All right, so let's start with a couple of details here. All right, so now, when we solve, notice this point of intersection. We're going to call that our anchor. And we're going to solve for that anchor, all right, the same way we solved your opener up here. The same way we solve an equation. We're going to solve for that anchor, all right? Now, just like what we did with lines, right? We have solid lines and dashed lines. Well, when we do what we're going to do today, we're going to have solid marks in our anchor or dashed or open marks. So when we have a less than or equal to or greater than equal to, we're going to mark our anchor with a solid dot, all right? In the same way we drew a solid line. Okay, when we have less than or greater than, we're going to mark our anchor with an open circle. All right, that's going to be kind of compared to like the dashed line that we did. Okay, so now what are we going to do? We're going to solve for that anchor. We're going to find that point of intersection where they're equal. All right, we're going to mark it. Now, the reason why we're marking this is because if it's solid, we get to include that anchor, that value, as part of our solution set. In the same way, when we had a solid line, we got to include the points on the line as part of the solution set. Now, here's what we're going to do. Just like we did with our inequalities when we were graphing them, we're going to test to see where the true side is, because we're always going to shade the true side. That's our solution set. All right? And so remember, 0 is the easiest number to test, so as long as our anchor is not 0, we should test 0. And then once we do that, we can write the inequality, just like I ended up with up here for parts A and B, all right, from what we graph on our number line. Okay? So solve for our anchor, mark our anchor, and then test, all right, just like we did when we were graphing. So you're going to see that the process is very, very similar to what we did with graphing our inequalities. All right, so let's flip the page here. Let's go to page 127 in our booklet. All right, so it should be, all right, I'm going to zoom out a little bit here so I can get all of this in our window here. All right. Okay, so here is, all right, our first example, number 1 here. 2x plus 4 is less than 6. All right? Okay, now once again, if we kind of think about this, this is slope-intercept form. This is a horizontal line, right? So we're asking, where is this line that's in slope-intercept form below that horizontal line? So what we want to do first is find where they are equal. So the first thing we're going to do is just rewrite this as an equation and then solve it the way we know how to solve an equation. So 2x plus 4 is equal to 6. All right, so notice I don't have to worry about any distribution or combining like terms, so I can go ahead and start by making one side equal to 0. So I'm going to subtract 6 and subtract 6. So I get 2x minus 2 is equal to 0. Now I can use my 0 property. All right, what minus 2 is 0? 2. So that means that 2x has to equal to 2. And then 2 times what is 2? 2 times 1 is 2. So that means x is equal to 1. So 1 is our anchor. That means that that is where these two lines intersect. That is where these two lines are equal. Now I'm going to mark that on my number line down here with an open circle because I have a less than symbol here. So just like we would have had a dashed line, we're going to have an open circle on 1. All right, so there we go, just like that. All right, so now we have to know either the right side is true or the left side is true. So we just need to test to find out. So notice I'm going to test 0, all right, and I'm going to plug that back into our inequality to see if that gives me a true or a false statement. So 2 times 0 plus 4 is less than 6. All right, so 2 times 0 is 0. So 0 plus 4 is less than 6. And so I get 4 is less than 6. Well, that's a true statement. All right, so that means 0 is on the true side. That means, all right, just like we did when you graph, the other side has to be the false side. And we always shade to the true side. So that means I want to shade to the left here. Okay, so I want to shade to the left. Well, look at all those numbers, right? 0, -1, -2. Those are all values that are less than 1. So my inequality would be x is less than 1. All right, so there's our inequality, right? That's how we solve an inequality. So we're going to find that anchor by solving the equation first, and then we're going to test, all right, just like we did when we graphed our lines. All right, so let's look at problem 2 here. All right, so once again, I'm just going to write this as an equation to begin our process here. So -6 times the quantity x minus 1 plus 12 is equal to -30. And I'm going to solve for where they're equal. All right, solve for where they're equal. So notice we have to distribute first here. So -6 times x is -6x. -6 times -1 is +6. And I bring down the rest of the problem. Notice I do have two like terms to combine here. 6 plus 12 is 18. So I'm going to do that. All right, and now I can get it equal to 0. So I'm going to go ahead and add 30 to both sides here to get our equation equal to 30. So -6x plus 48 is equal to 0. All right, now once again, when we think about, all right, our 0 property, what plus 48 is 0? -48 plus 48 is 0. So whatever's behind my hand has to be -48. So -6x equals -48. And now it's a multiplication problem. -6 times what is -48? And the answer would be +8. All right, so +8, all right, is our anchor here. All right, so that's where these are equal. So I'm going to mark that on my number line. Now once again, I'm going to go back and look at my symbol. It's greater than, all right, so that's going to have an open circle. Okay, and then once again, now we want to test. So now I'm going to take 0, which is on the left side again, and I'm going to plug it into our inequality, and I'm going to see what result we get. So -6 times 0 minus 1 plus 12 is greater than -30. All right, so we just follow order operations here on the left side. Do our parentheses first. 0 minus 1 is -1. Then I'm going to do my multiplication. -6 times -1 is +6. All right, and then 6 plus 12 is 18. All right, now is 18 greater than 30? Right, that is a true statement. All right, so that means 0 is true. That means this side is false. Once again, we want to shade to the true side. So in this case, that's this side again. Now, once again, if I'm going to the left of 8, right, all those numbers are less than 8. So my inequality would be x is less than 8. All right, so there we go. All right, so now let's do one more together here. Let's do number 3. All right, and that'll end our lesson for today. All right, so now, once again, we're going to start by just rewriting this as an equation. Just going to slide this over a little bit, give me a little bit more room for my hand. All right, so notice we don't have to worry about distribution here, but we do have two sets of like terms on the left side. I've got two x's, so 7x plus 3x. All right, so that would be 10x. So this plus this. All right, and then I have two other like terms. -10 plus 12 would be +2, and then that's equal to 32. All right, so now let's get that right side equal to 0 by subtracting 32 from both sides. All right, so 10x minus 30 is equal to 0. Now we can use our 0 property. All right, so what minus 30 is 0? 30. So that means 10x has to be equal to 30, which means that 10 times what is 30? That means x is equal to 3. All right, so 3 is our anchor this time. That is where these two equations are equal. Now, once again, we still have another open circle because we're greater than. So I'm going to put an open circle on 3. All right. Now, once again, I'm going to test to see which way to shade. So I'm going to test 0, which once again is on the left side of our anchor this time. All right, so I'm just going to drop down just a little bit here. So 7 times 0 minus 10 plus 3 times 0 plus 12 is greater than 32. All right, so 7 times 0 is 0. Bring down the negative 10. 3 times 0 is 0, and then I'm going to bring down the 12 here. All right, and then negative 10 plus 12 is 2, and so I get 2 is greater than 32. Well, is 2 bigger than 32? No, that is false. All right, so that means 0 is on the false side, which means now the right side is the true side. So now I want to shade to that right-hand side. So this is the way I want to shade. Well, notice this time, all right, we're getting all the numbers that are bigger than 3, right? So 4, 5, 6, 7. So our inequality then is x is greater than 3. All right, so that wraps up our introduction to solving linear inequalities. All right, we'll pick back up and we'll do a few more examples in class next time. All right, so make sure you do your video check-in, and I will see you soon.